Alright, in this video we're going to take a look at our last conic section, hyperbolas. So I have a picture of a basketball here, and it actually has a hyperbola on it. What a hyperbola is it's two parabolas that are going away from each other. So if this is going forever that way, that would be a hyperbola. We can also have a hyperbola going like this. We call this a horizontal hyperbola, and we call this a vertical hyperbola. Alright, so let's take a look at the equation for hyperbola. You'll notice up there, it looks very similar to our ellipse equation. There's only one difference. See if you can spot it. And the difference is right here. That minus sign completely changes the shape from my ellipse to a hyperbola. So graphing hyperbola is pretty easy. We have a center of HK, and this A and B are going to be like our axes in the last lesson in the ellipse. So let's dig right in and look at an example here. So if I have something like x minus 2 squared plus y plus 3 squared equals 1, we'll make this over 16 and this over 9. Alright, first thing we do is graph the center. The center of this is going to be at 2, negative 3. So over 2 down 3. And we know that the x-axis is going to be at 4. The y-axis is going to be at 3. So x-axis is 4. We're going to do just like we do with the ellipse 4. 1, 2, 3, 4. And 1, 2, 3, 4. And the y is up 3 and down 3. Alright, this is where it changes. So we have these points, and we're going to take them and we're going to make a rectangle around them. Alright, so let's make a nice rectangle around these points, and this is going to help me with my ellipse. Alright, after I do that, I'm going to make a line going from the center through the diagonal. Alright, like this and like this, and like this, and like this. I should have made a dashed line, so let's dash that real quick. Dash, 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 dash. Because this is actually an asymptote. You remember asymptotes from before. Lines do not cross asymptotes, so these are some diagonal asymptotes. We haven't seen those before yet. So this hyperbola is going to start here. This is a horizontal hyperbola. It's a horizontal hyperbola because the x comes first. It's going to start here in our box, and it's going to go up, and it's going to come close and close and close, but never actually touch that asymptote. It's going to do the same thing down here. And from the left to the right, it's going to go up like that, and it's going to go down like that. So they're mirror images over each other. Same thing's happening on the left side as the right side. Alright, let's look at one other one. This is the equation for a vertical ellipse. Alright, so let's make one up here. Y plus 2 squared minus x plus 3 squared over, there's that battery again, keeps going low. We'll say over 9 plus 1, and we'll say over 4. So it should be a smaller looking box. So first we need the center. The center is going to be at negative 2, negative 3. So my center, negative 2, negative 3. Now we're going to make the box for this ellipse. So the box, the y value is going to be up 2, down 2. The x-axis is going to be 1, 2, 3, and 1, 2, 3. So now I can make this box here. And I'm going to go ahead and make my asymptotes. So a dash line going something like that. It'll be going down something like that. It'll be going down like that, and up like that. So my hyperbola is never going to cross those asymptotes. Now if I draw my hyperbola, since we have this y value first, and then it's minus the x value, that means it's going to be a vertical parabola. So it's going to look something like this. It's going up, and it's never quite going to get to that asymptote, right? It's doing the same thing down here, and the same thing over here. The asymptote's pulling it closer and closer and closer, but it's never actually going to touch it. We can graph these in the calculator the same way we've been graphing all the other ones as well. There's a function for the hyperbola. And that's it. That's the hyperbola. So this is all of the different conic sections for the unit covered that you'll be working on with your project. I will see you in class. Have a good one.